All right, welcome. Here we are at 7.1. We're going to be talking about exponential functions and more specifically growth and decay. And what you're kind of noticing here is a pattern in the chart here. We're going from 60 to 120 to 240. So we're going to be multiplying by the same thing every year. And that's what exponential growth looks like, is that it's a multiplication. Now in linear, we're adding the same thing. With exponentials, we're going to be multiplying by the same thing. So these parent functions that we have of the exponential function is basically going to be, as we talk about, b is the base of the exponent. That's what we're multiplying by. X is the exponent, which kind of tells us, well, how many times are we doing this? Okay, so that'll tell us how many times to multiply by that base. And so we kind of look at some graphs as well. A parent function simply would be like 2 to the x, so we're just multiplying by 2 every time. You'll see that upward growth that we have, very simply seeing that it is growing, and that's multiplying by 2 every time. All right. With a lot of times with these functions, you're going to see an asymptote is that we're never going to get down to 0. It gets closer and closer to, but never actually gets there. And that's something to kind of pay attention to. All right, now with a difference between exponential growth and decay, you can always tell. Now, A is going to be what you start with. B is what you're going to be multiplying by, and X basically tells you how many times you're going to do it. Growth basically is going to be if that base of the exponent, if it's going to be a number that's bigger than 1, it's going to grow. Now, if it's 1, it's just going to stay the same, which doesn't make any sense. But if it's going to decay, things like when you're metabolizing medicine, trash that decays, those types of things, what you're going to see is that multiplier is going to be somewhere between 0 and 1 is what we're going to see there. All right, so let's kind of get going here a little bit. Yeah, okay, so again, we talked about those types of things. So a lot of times we can give you a graph or a function, and you should be able to easily tell if it's growth or decay. The big thing here to take a look at, looking at the graph, you can see that it's going up, so it is growing. The other thing to take a look at is the base of the exponent. Again, you can see there clearly that number is bigger than 1. That's a 5% increase. So remember, when we're increasing by a percentage, we always add that to 1 is what we do. All right, so basically speaking with exponential functions is that we're going to start with A. A is what you start with, the initial amount. And then we're either going to go 1 plus or minus the rate. Now, if it's a decay, if we're decreasing by 10%, we're going to take 1 minus 0.1, which of course then the multiplier becomes 90%, 0.9. If it's a 10% increase, we're going to add it to it. So 1 plus 0.1, so 1.1 is what that's going to be. Now, a lot of times the fun things to use these for is for money type of problems where we're investing. And let's just say that we had $5,000 in an account. It's going to pay 6.25% interest per year. After how many years will our investment be worth $10,000? So what we can do is we can kind of write an exponential equation. What do we start with? Well, we start with 5,000. All right, it's a 0.625% increase, so we're going to add that to 1. So it's going to be 1.0625, and we're going to raise that to the x power. We're trying to find out what x is. And as of right now, what we're going to do is we're going to put that into a calculator is what we're going to do. All right, so let's just kind of take that, and let's put that into the y equals here. And let's see, we're going to go 5,000. Whoops. Let's go back here, 5,000, and then in parentheses, 1.0625, and what we're going to do is raise that to the x. All right, hit enter. Then what we're going to do is we're going to make ourselves a little table here, second table, and look at that. We can see what that growth is every year, and basically we want to say, well, when does that get to 10,000? Well, okay, we can scroll down. And there we go. We're getting there. Okay. Yeah, looks like about 12 years. 10,349 would take us about 12 years. We could change the domain there if we wanted to find it more specifically. But we'd say about after 12 years, we would get that, is the story there. So it's kind of nice to be able to use that table mode to be able to scroll and you kind of see what's happening and behaving each thing of the way. All right, let's try to do another one here. Now this time, using the split screen here, let's see, this time we had, let's move that out of the way. What does that say? Okay, $15,500. Population has been dropping by 3% a year. We want to know when is it going to get down to 8,000. So once again, we're going to start with 15,500. And since we're dropping by 3%, we're going to minus that from 1. So what's remaining is 97% is what remains. And we want to know what happens there. So let's go back to the y here. Let's clear that out of there. Let's go 15,500. What we start with, we're going to go 0.97. Since we're decreasing by 3%, we're going to raise that to x. There it is. And so now what we're going to do is make that table. And now we want to scroll until we get to 8,000. Okay, kind of see what's happening to that population. Oh, there it goes. So, yeah, so once we get to about 22 years, that's going to get below 8,000 is what we're looking at there. So using that table mode of the calculator is great. We're going to talk later on this chapter about how to solve for x if it's an exponent. But for now, let's just kind of use the calculator and do that. Okay, so that's 7-1. Try the assignment there in Moodle and work with that calculator. If you have any questions, obviously make sure to contact me and I'll get back to you as soon as I can. All right, until then, next time, I'm Mr. Bill.